Welcome to our video series Easy Experiments to Understand a Complicated Earth. This series is produced by Escuela Nacional Preparatoria and the Centro de Geociencias Campus Juriquilla, UNAM. Hello everyone, especially you who are watching this video. My name is Sandy, and today I have a scientific question to solve. You may have the same one. Would you like to help me? Let's look for the answer. We are almost ready, but what do we need for the experiment? So easy, my friend. A coin? Don't worry about the price, doesn't matter right now. A vessel or a cup? The only condition is that the material has to be transparent, like glass or plastic. Why? So we can see the phenomenon really well. A pencil? Yes, the one which you are writing with right now. Finally, we will need a container with water. So now that we are ready, let's go! Let's make science. Introduce the coin and some water in the container. We are looking two images of the coin. One is real and the other virtual. Let's see it again. Pay a lot of attention. Introduce the pencil and some water. Now we can see a virtual image and a real one of the pencil. Let's see it again. Pay a lot of attention. You might be thinking, what happened in our experiment? Well, let's find the answer. And for that, we will use our amazing blackboard. Come on! This phenomenon is known as refraction of light and was discovered by Snell. First, we need to understand that two mediums are implied in this theory, which is why I make a blue line, dividing the two of them. Here is the medium of light. And here is a fluid known as water. And of course, the light. You may ask, different mediums? Where can I see this? And for that, I choose one of my favorite places, the beach. Here we can see the medium of air and water. When light travels from a transparent medium to another with a different refraction index, which means they are different, one part of the light would be reflected in the same angle as it entered. This is known as the reflected angle. For its study, physics draw a line where the angle of reflection is made. This line is known as the normal. The rest of the light will pass through the material, but in a different angle, which is known as the refracted angle. If light goes less faster in the second medium, the angle will move closer to the normal, which is the case between air and water. And basically, that's what happened in our experiment. We can see two mediums, the normal, and how because of that, light was reflected and refracted. This image is a virtual image compared to the one we see when we only have a medium. So light goes straight and we see a real image of the coin. Finally, temperature takes part in this phenomenon. How? Well, the air which is closer to the floor has higher temperature to the one in the upper part. Higher temperature makes the refraction stronger, and is the reason of why objects seem closer comparing to the real position. Do you think we can see the phenomenon of the refraction of light in our lives? Of course we can. As you can see, refraction of light is everywhere. It's part of our lives. We can see it in nature, for example, in a rainbow, in the art, in games or figures, or even when we take a snap with a straw or practice an sport like swimming. Now you know the truth behind each experiment. Let me ask you a question. Do you think the refraction of light is present in a mirror? Yes, when you look yourself every morning, Can you see this phenomenon? And remember, the next time you go to the beach, just look around carefully. And remember that science means to be curious. So, come on, let's be curious. See you!